Hello everyone. Continuing from last week, time management, we discussed last time work breakdown structure and we discussed the network diagram using the Gantt chart. It is important how we can realistically estimate time for project management. We're going to discuss today more in detail the network diagram, critical path analysis and critical path method for managing time in order to ensure that the project is estimated to complete on time. Because time management is essentially the ability to officially or efficiently utilize time spent on various tasks in a particular day or both major and minor tasks, which involves organizing and planning how to divide the time between different tasks of the project. So time management is obviously one of the key aspects of effective project management, assigning time to the various tasks, which is quite important for timely completion of the project. This also means breaking down the project into different tasks. If this is not appropriately or smartly managed, then poor time allocation can lead to ineffective decision making, which gonna definitely increase stress within the project team. The time management, one of the technique we use work breakdown structure. We decompose the project. Now from the work breakdown structure, we get the list of activities, all major and minor, when we do decomposition or deconstruction of the project, and then we get all this complete list of activity to insert in the Gantt chart. And now it is more important for us to make sure how the resources will be allocated and how the activities can be completed one after the other or side by side. So the project network diagram is a key technique which is giving us a visual representation of the workflow of a project. A network diagram is a chart. Basically, it is a diagram of a relationship between nodes and through arrows. A network diagram is populated with boxes or circles noting tasks and responsibilities, and then arrows that map the schedule and sequence that must be completed before we execute the project. Because critical path method is a one key tool, and critical path analysis, it is important we are using in the algorithm for scheduling a set of project activities. It is quite common, which is used in conjunction with the PERT as a project evaluation and review technique. So during this activity, we need to basically find out the duration for each activity to complete, to identify float or slack activities or critical activities, and we need to find out with a critical path which is going to be the largest part to complete the project in the shortest possible time. So we are looking at how exactly we mean by critical path. What is critical path analysis? CPA, a critical path analysis, is a project management technique that requires mapping out every key task that is necessary to complete a project in time. It includes identifying the amount of time necessary to finish each activity and the dependencies of each activity on any others activities within the project or other projects within the program or portfolio. So critical path analysis is a widely used project management technique for scheduling projects. It uses or it is used to see which actions impact the overall schedule. So critical path analysis is a project management technique that requires mapping out every key task that is necessary to complete a project. That means it indicates identifying amount of time necessary to finish each activity and the dependencies of each activity on any other one or before the precedent or the successor activities relationship. So we recap from the WBS. We know this is the key characteristics or key principles we do decomposition, deconstruction, break down the product or the project task, divide the complex project into transform from complexity to simplicity, and this simpler manageable task we need to identify through work breakdown structure. And we know when we define work breakdown structure, we basically looking for deliverables oriented graphical or flow chart or hierarchical presentation of the work to be executed by the team to accomplish project set objectives. And that is the key purpose, to define overall scope of the project with all the activities, every single small chunk of work to be completed to achieve the overall scope. So the breakdown of the large activities in comprehensible or manageable unit is the key principle of work breakdown structure, or sometimes we can use product breakdown structure instead. So this is one of the example we discussed last week. For example, we had to build a house, how we decompose in key milestones and then further subdivide each deliverable with small chunk of work, and then we can decompose from level 1 to 2 to 3, and it can go further down, and we can even reach to level 4 and 5. Depends how much in go in detail for decomposition. So the activity list is a comprehensive list, include all scheduled activities required by the project team, and we get this and insert in the Gantt chart. So the activity list is the action basically needed to complete the project deliverables. And we know from the last week we discussed that these are the key attribute, and we have the relationship, for example, between the successor activity and the predecessor, if they are going the activities side by side or one after the other. So the information is quite important to schedule each major minor task and get the estimation for the overall project to complete on time. We get this an example as we discussed last week. We get the list of activity, we put them in the Gantt chart and get the graphical bar representation for each activity to perform. And if we take this as an example, we know that each activity has its numeric or alphabetical code. The activity is being described in the column in the row of the table for the description, and then we know the precedent activity, and from this table we basically get the network diagram, and that is very important. This is the graphical illustration of the activities. They are dependent, or they can be performed side by side in parallel or in sequential order, one after the other. So when we looking to the critical path analysis, the technique we are applying, we basically trying to formally identify tasks which must be completed on time for the whole project to be completed on time without delays. CPA also help to identify which tasks can be delayed for a while if resources need to be deployed or to be reallocated to catch up on a missed task or the task which is critical and they need urgency or priority to complete. CPA help to identify the minimum length of the time needed to complete a project, and CPA determines both early start and the late start date for each activity in the schedule. So from between start till end, we need to find out how this activity can be performed one after the other or side by side. But what is the start and end of each activity? What is the early start or late start or early finish or late finish for each activity? This is quite important technique as a lifetime learning for project manager. So the critical path analysis keys are based on this important understanding that you learn the early start and the early finish, late start and late finish for each activity in order to understand or to identify the float, which is sometimes called slack or critical activity. So the duration we have estimated, and then we need to calculate for each activity. We have to do this exercise that the activity is being identified with the early start and finish and late start and finish, and we also have to identify if the activity is critical or is non-critical. So that is quite important, that how we do early start to late start, early finish to the late finish when we're going to forward on backward. So we use forward pass and backward pass to understand the calculation for critical path. And when we're going forward and coming backward, the answer when we want to find float, so we minus late start from and then we minus the early start from the late start, or if we subtract the late finish into the early finish, answer should be always the same. If the answer is 0, that means this float is with known tolerance. This is critical. There is no absorption capacity. If it is more than 0, let's say 1, 2, 3, whatever is the number, that means the higher is the number, we have more tolerance and we can delay this activity. Let's say if it is 3, so the activity can be hold on for 3 days, will not affect and to delay the project. That's the absorption capacity, that is the tolerance level of that activity. If it is 0, it means it's critical, no tolerance, it cannot absorb, we cannot afford delays. I hope this makes sense, but we will discuss in the workshop more in detail. Simple activity list, for example, if this is the activity we are performing with the alphabetical coding, and this is the estimated, this is our best estimation, how much time should be given to each activity to complete. So the duration, we ideally believe 3 days, 4 days, 6 days for C, and 2 days for D. But you can see the precedent activity. This is very important. So the activity A has no precedent activity. So we just start from here. B dependent on A, C is dependent on A, D is dependent both on B and C. So first we draw the network diagram, and this is important that we know how this will work. A has to complete as a start of the project. B and C will start side by side soon after the A, and D can only be started when both B and C are completed. So we can do the same technique to apply for each activity. So we have A, B, C, D, 4 activities, and now we know the duration from the table, that each activity has been estimated with the right estimation for each duration of the activity. We'll put the duration for each activity, let's say in the grid of this graphical illustration in the matrix, and we see A is 3 days, B 4 days, C 6 days, and D 2 days. But now we need to calculate the early start for A, early finish for A, and similarly we go forward till the end, and then we come backward to calculate the late finish and late start for each and every activity in this project. Okay, so we are going from left to right as a forward pass, and we assume we start right now, 0 time, and then we do simple mathematics. 0 plus 3, that is the duration. Well, the early start is right now 0, so the early finish for A is 0 plus 3, so it should not take more than 3 days. So early finish is 3. There's no delays. And this early finish for A will become early start for both B and C. Soon A is finished, we start B and C. So we have early start for B 3, early start for C is 3 again. Now we add again, we do the simple maths, addition. Early start plus duration, it will become the early finish for this activity, and early start plus duration will become early finish for C. And then when we're going forward, now we have 2 options here. So we will choose the higher value going forward, always maximum value going forward. So the early start from here plus duration will become the early finish, and that is the end of the project, and that will be the total time we can allocate. And then we go backward. So let's go to the next slide. So this forward pass, we calculate till the end, and you can see here the same mathematics we have done, 7, 9. The maximum value forward pass, between 7 and 9 we have to choose 9. That will be the early start. So early start plus duration, 11 is the early finish for the D. So the total time gonna be 11 days. Now when we're going backward, so we have to forward we were doing addition, backward we are doing subtraction. So now the early finish for D minus its duration will become late finish for D. So we don't want to delay this project. We don't want to give extra time. So we assume we're going to finish in 11 day. So 11 minus 2, that will be 9. So we put 9 here, and then we take the activity which we believe is the late finish has to be what will be the late start here. So look to the next again. So 11 came here. We don't want to delay. 11 minus 2, 9 is the late start. So we have the late finish 11 and the late start 9. It means if we minus 11 from 11 or 9 from 9, that means late finish minus late early finish, or late start minus early start, answer should be the same. Here you can see answer is 0. So we will put 0 here as a slack, that's the float. So the float in this case is 0, because 11 minus 11, 9 minus 9, answer is 0. So we put this 9 as a late finish for the president activity. We do the same subtraction here. 9 minus 4, 9 minus 6. So we know that this will become 3, and we do 9 minus 4. So you know what is the answer. It is 5. Now when we're going backward and we have two options, here is 5, here is 3, we always choose minimum value. Forward maximum, backward minimum. So 3 will come here, and then we minus 3 into 3, answer will become 0. So we can see here that this is how we done the mathematics backward. 9, we done the duration minus, and we get the late start for B and C. So late finish, early finish minus late start minus early start, answer we will find here. But here we have 5 and 3. We take the minimum value as a late finish minus duration will become the late start for A. Now we need to calculate the slack for each activity. So you can see 11 minus 11 or 9 minus 9, answer is the same. Again here 9 minus 9 or 3 minus 3, answer is 0. Here 9 minus 7 and 5 minus 3, answer is 2. It is not 7. So this slack is not 0. It is 2. Now we calculate here 3 minus 3 or 0 minus 0, answer is 0. Now from this we can understand that this is 0, C is 0, A is 0 with a slack and float. But B has tolerance level 2, so we can hold on this activity if you want. Our resources can be deployed, but this activity is not critical. But these activities are critical. So we know the critical path is A, C, D. So B has a tolerance, it is non-critical, but this will be our critical path. So the example here again, you do the same exercise, you apply, you know the duration from the table, you get the duration, you know the precedent activity, you create the network diagram, and after creation of the network diagram, put the activity name and the duration and do the simple mathematics forward, backward, calculate early start, early finish, late start, late finish, and when you do this, you get the total duration, and you come backward and you find out the activity which has a 0 tolerance, and then you identify the path which is critical. Any activity with 0 tolerance is critical activity. Activity with more than 0 that has absorption capacity, and that's non-critical activity. So this is another example. You can see how we calculate slack or float. Sometimes you call it critical activity, sometimes slack or float. have the same meaning, and we can find out the critical path here. If you take this example again from this table, and you sit and you do it, either you can do in a group virtually, or you can sit to do yourself and draw the network diagram, apply the forward path, and then apply the backward path, identify the activity with zero tolerance, and then you have to identify the critical path through critical path analysis. And if you apply, this will look like from the table a network diagram, and then you do the forward path and backward pass, and then you can find activity with zero float or zero slack. These are the activity with critical nature, and this activity lying in the path, this is called critical path of the project. I hope this makes sense. So if you take the example of same the cup of tea is easy to do a project, but again, how we do the critical path. So we know the duration, start 0. We allocate time and the precedent activities. We apply that, let's say, how many minutes it will take. So we apply 1 minute for each thing to do. This is just assumption. We assume 8 minutes for the water to boil, so on and so forth. We do the network diagram. We again apply the same techniques, forward pass, backward pass, and we find the critical path within this project. Please share your thoughts and ideas how critical path is important on the week 6 discussion forum. Read between the lines and keep safe. We'll talk in the workshop this week. Bye-bye.